Thank you everyone for joining. This is super exciting. So my name is Val. I am one of the leaders of the Bloom organization that is hosting this event tonight. And Bloom is a organization that helps women and genderqueer folks learn about blockchain and Web3. So we just started our first cohort, and as a part of that series, we're doing some fireside chats with other people in the industry who have expertise in different areas, and we'll be kind of sharing that expertise with the rest of our community here today. So I'm really excited about this one, in particular because Mauve, you're an expert on P2p and Web3, and I'm aspiring to gain more expertise in that area as well. So thanks for being here. I will let you kind of give your introduction of yourself so I don't butcher it, and then you can proceed from there with the presentation. All right, so I'll let Mauve take it away.
Yeah, thank you so much for the warm intro. So hello, today we're going to be talking about the decentralized web, how peer-to-peer protocols and peer-to-peer data structures work, and how you can make local first applications with all that. So my name is Mauve, my pronouns are they, them, and I've been doing consulting on decentralized tech for a few years via my company Mauve Software Inc. You can reach me either on Twitter or on my website, or find me in the street. So before we get to the web and local first and all of that, let's take a look at what peer-to-peer means and how it relates to other software that you might be used to. So most applications today builds on top of this thing called the client-server architecture. So this is where you have a server running somewhere, probably off in the cloud, usually managed by somebody else. And you need it in order to exchange data with other people. So for example, if I want to send a file to a friend, so I'm the cool emoji here with the flushed emoji as my friend, I got to send it to the server first. And then once the server has the image, the friend needs to now pull the data from the server. So this is handy because a server can stay online for me. We don't have to be somehow like emailing things directly to each other. We can just kind of wait until one of us wants the data. And as well, servers are nice because they can help prevent people from accessing the data with access restrictions. So if I want something private, maybe it's like, I don't know, my baby pictures, I don't want that exposed to everybody. Servers can have access restrictions so that only my family can access it, for example. However, servers are also kind of brittle when it comes to outages. So whenever a server becomes unavailable, or one of the people in this transaction of I upload, you download, whenever any of these things become unavailable, the system just doesn't work anymore. So this can happen most commonly these days is if a company shuts down and suddenly all of the data that you were using, all of the functionality you had is just gone. This also happens if, say, a data center goes down. So we've probably heard the stories of like Amazon going down and suddenly like your smart fridge won't let you like eat your vegetables or something crazy like that. So as well, this can happen if the business itself doesn't want you to share a file with your friend. Like say you're a member of the LGBTQ plus community and you're trying to say lesbian on TikTok, you get censored because they don't want you on their platform or whatever else. Or for example, recently OnlyFans decided they don't want sex workers on their platform anymore. And they can just choose that, and people don't really have a choice but to go with what the server says. So finally, sometimes it's not so much a reason of servers being down. Sometimes it's, you can't connect to the internet. So if either I go offline and can't upload my data, or my friends can't reach the internet, or maybe say we're in a place where we just can't connect to that particular server in that particular region, suddenly nothing works at all again. So you might experience this if you go on a trip somewhere outside of your cell phone coverage, and suddenly you have like a very fancy, very expensive brick that just can't do anything because everything relies on these central servers. So, so gloomy. The alternative is to use peer-to-peer applications because they are fundamentally different from the client-server architecture. So instead of going through a server to send data to somebody, we send it directly to them. So this works by taking really two steps. One is if you have some data, you announce to the public peer-to-peer network that if someone wants it, they should connect to your computer. And then if you're somebody looking for data, you look up on the peer-to-peer network to see who has the data you want and connect to them. And then there's some protocols in between those two for actually establishing the connections. So this looks something like me wanting to tell the peer-to-peer network if someone wants my cool cat picture, they can connect to me. This person now asks the peer-to-peer network who has that cool cat picture, and then they connect directly to me and download it to their computer. So now they have a copy of it on their computer, and they are actually just as privileged in the network as I am being the creator. So they can reshare that to others and information can virally propagate. So essentially what this means is even if I go offline, that data doesn't necessarily go offline if somebody else has a copy. So say this cat emoji person comes by and they want to download the image. Even though I'm not in the transaction anymore, this flushed emoji person can provide the image to them. And as well, everyone that has a copy of it can use it offline. So if I have a local first app that is like my notes app, all of my notes will work offline by default, regardless of whether I'm connected. It's possible to do this with a client server architecture, but it usually requires a lot of engineering effort. Whereas with here, you kind of get it for free. So question in the chat, how does security work on peer-to-peer? So really good question. We're actually going to get into that in just a second. TLDR, cryptography, and encryption on the transport level and on the data itself. Of course, there's also webs of trust and all of that, which we won't be going in just yet, maybe at the end if we have more time for Q&A. So speaking of connections and securing them, let's look at how the network works in a peer-to-peer network. So the core of most of these peer-to-peer protocols is their peer discovery mechanism. And this is what lets you advertise to the world that you have data. And this is what peers use to find people for data. So one of the most integral pieces that most peer-to-peer networks use is called a distributed hash table. At a really high level, it's kind of like a hash table or a hash map or a key value store, all the same stuff, but it's fully decentralized and distributed. So that means there's no single source that contains all of the keys and all of the values. So the DHT is comprised of all of the peers in the network collaborating together to store a small subset of all of the data. So this works by assigning every peer in the network an identifier, and that identifier being the same format as the identifiers of data on the network. So this is going to be a little technical. So I encourage you to look at diagrams after the fact. So this uses algorithm called XOR distance. By this, I mean Kademlia, which is the most common DHT protocol. So what this means is given two IDs, I can get a distance between those using some simple math. And the way this helps us with peer discovery and distributing data is that peers will remember the IP addresses of others that are close to their ID, and also a few others that are further from their ID. So this means that when I want to find some data, I find the peer that I know that's closest to the ID. Then I ask them, who do you know that's closer to the ID? And then from the peers they give me, I'll find who they know that's even closer to the ID. So what this means is that I can really quickly narrow in on whoever is closest, because at every step, I'm cutting out a huge swath of the total nodes in the system that I don't actually have to query anymore. So once I've found the closest peers that I can, there's no further to go. If I'm announcing to the world that I have data, I tell them, hey, if someone comes by looking for this data, send them to my IP address. And then if I'm looking up data, I will ask them, hey, who do you know for this ID? And give me their IP address so that I can connect to them. So that's kind of the gist of the DHT. And this is how a lot of protocols let you connect to each other without having any central repository. So with this algorithm in place, there's no central authority kind of controlling what data can exist. there's also no central server to go down. Since it's distributed, even if like half of the nodes go down tomorrow, it doesn't matter because everyone can kind of like balance the load amongst the remaining nodes. And this is very powerful for keeping a network kind of healthy and truly decentralized. So one other thing that's cool about DHTs is you can actually host them for your own community. So say you have, some people, maybe this is like a physical community where you live near each other. Maybe this is a digital community where you're all part of the same digital tribe. You can set up your own DHT for hosting data just for yourselves and kind of collaboratively share the load of exchanging data. So speaking of local networks, the other thing that a lot of peer-to-peer protocols give you is local peer discovery. So with the DHT, usually you need to connect to the internet, but what about when you can't connect to the internet? So with that, there's a different tool in place called multicast UDP. So this is a feature of most IP networks. So most of your like Wi-Fi networks or some cell networks or whatever else, where instead of connecting to a single person and sending data between the two of you, you can instead broadcast to anybody on the network that's listening on a special IP address. So practically, this means that if I am loading up my peer-to-peer protocol and I want to find that cat picture on my network, I'm going to broadcast to the network saying, hey, who has this cat picture? And then one of the people on my network can respond to me saying, hey, I have a cat picture. And then from there, we can connect directly to each other and do the little peer-to-peer dance. So what's cool is this works without the internet, without having to configure anything. It just means that if two devices are connected to each other somehow with IP, all of the peer-to-peer applications work. So any applications that use this enable you to have cool things like you could be in like a festival in the woods. And if you have a router set up, you can start exchanging data, like sharing photos or sharing information about the event or like, what mushrooms are safe to eat without having to worry about, extra file transfer apps or having to like go through these intermediate servers that are in the cloud, which you probably can't access. Question in the chat, does it only work on closed nodes? Is this talking about the local peer discovery or the DHT? Yeah, so this is a little tricky. So it's not necessarily how close you are physically. It's more about how close you are on the network. So typically, the most common use case that you'll see, which is probably the easiest to reason about, is a Wi-Fi router. So if you set up a Wi-Fi router and have a bunch of devices connect to it, all of those devices are now on a local network. So even if you're physically like in opposite sides of a house, they're effectively the same distance from each other as far as the Wi-Fi is concerned. So in that case, everybody will be receiving the messages in the same way. However, if you have a more complicated setup, for instance, an ad hoc community mesh network where people are just kind of like networking the routers together and then you have like a whole mismatch, then closeness might be that you're only asking for people a certain number of hops away. So it's a bit nuanced, but in most situations that you're going to encounter, closeness just means we're all connected to the same network layer somehow. Other question, how about performance optimization within wide groups in terms of speed accessing data and also issues of storage, which is a big plus of cloud servers? Yeah, so I think what this person is getting at is how if you have massive amounts of people all trying to load the same data, if you're all just connecting to each other directly, can it really outperform a data center? So with regards to the DHT, what's cool is that it scales very well with lots and lots of people getting together. And as you have more people, the more popular some data gets, the more people are resharing. This means that you can download from more people in parallel, and it kind of automatically balances the load around everybody on the network. So that's actually a benefit compared to cloud servers, where in the cloud, if two of us are watching the same Netflix show at the same time, we both have to connect to Netflix's data center and potentially download the exact same data twice, even though we could potentially exchange data directly over our local network and skip the cloud altogether. Another point being raised here is issues of storage, which is a big plus of cloud servers. So yeah, so with the clouds, one thing that it's really done well is making storage super cheap. So if you're using AWS or Akamai or whatever CDNs, you can store like gigabytes of data for pennies, which is great. However, you then get into the situation of all of your data is dependent on these storage providers. And suddenly, if you want to use it, if you don't have that internet connection, or if the server goes down, or if you don't have the money and the technical know-how to keep all of that stuff updated, suddenly it becomes a lot harder to work with, or you become a second-class citizen that doesn't actually own their data and instead is beholden to whatever tech platform is doing things for you. There are some things that are trying to address massive storage in a decentralized way, particularly IPFS's Filecoin and some other blockchain adjacent things that are trying to distribute load. However, you can oftentimes just like get a server, have it sitting at home, and then just make sure it's backing up your data. And you can get like pretty cheap usage, which also gives you a lot of privacy and resilience against outages. Question in the chat. Sorry, I think I phrased it strangely. I wanted to know if the ability to get the cat picture, for example, without connecting to the internet only works on a local network. So it depends. Usually, yes. So most of these peer-to-peer protocols, they're following the assumption that you're going to be on the same Wi-Fi network and you can exchange data. However, with peer-to-peer protocols, the peer discovery mechanism is flexible. So people have used stuff like Bluetooth, where if we're physically close to each other with our phones, we can potentially connect to each other via Bluetooth or Wi-Fi Direct or whatever and exchange data that way. So if you're not connecting to the internet, you potentially don't need to even connect to a local network and do something ad hoc. However, the most common use case that you'll probably encounter, unless you're working with people in low infrastructure environments, is probably going to be your home Wi-Fi. Cool. Great questions. Thank you. So now that we talked about the network a little bit, let's talk about the data or the content that we're actually exchanging. So an important distinction between peer-to-peer decentralized networks and client-server centralized networks is the way trust works. In a centralized scenario, you trust that the server you're using isn't lying to you. And on top of that, you might encrypt your connection to them so that you know that nothing in between you is tampering it. However, at the end of the day, the server could just say that, 2 + 2 = 5, and your computer will just trust it because it's not doing any extra verification beyond that most of the time. In a fully decentralized system, if we go back to that scenario where we had me sharing a picture to a person and then that person sharing with another person, how does the third person know that the second one hasn't tampered with the data somehow? Maybe they replaced the cat picture with the dog picture, and that had completely changed the vibe. So this means that when we're downloading some content, we need some sort of way to verify the content as part of us defining what the content is. So confusing phrasing, but let's look at what this means in practice. What a lot of systems use is this thing called content addressability, where rather than referring to content by arbitrary names and trusting an authority to map the names to data, you instead have the content and the identifier to the content closely linked together using this thing called hashing. So with hashing, you essentially take some data, put it into a hash function, and it gives you a smaller ID for that data. If any piece of the data changes, you get a totally different ID. So practically, it means that if I want to share some data and have people be able to verify it, I'm going to hash my data, in this case, hello world, and I'm going to get back the identifier ABCD. My friend will then see the identifier ABCD and want to download it from the network. So they'll either get it from me or from someone else that has it. Doesn't really matter, because once they've downloaded it, they can verify whether the data is what it is supposed to be by hashing it and comparing it to the ID. If the ID doesn't match, it means something went wrong. Either the peer we got it from is malicious, in which case we might want to block them, or it might just be like literal network issues, which, it happens. So with this in place, trust moves from authorities to the identifiers. So if I trust that the ABCD identifier you sent me is valid, that means I can download data from anyone without having to trust them to not lie about what the data is, because I can verify. However, hash functions are a little computationally intensive. So what happens when you have a lot of data? So Merkle trees are another data structure which is kind of used everywhere in the decentralized space. And what they do is they take the idea of hashing data, but apply it to large chunks. So say I'm trying to download Big Buck Bunny, this wonderful short film from the peer-to-peer network. It's not very realistic for me to download the entire thing and then hash it and then verify whether I can view it before I can view it. What would be useful is if I could download chunks of it at a time and verify those. So a Merkle tree provides that structure. The way it works is it separates your file into individual chunks, and then it builds up a sort of tree structure on top with a root node acting as the identifier. So the hash of the root is the identifier for the entire tree for the whole data set. What this means is that every bit is content addressable, and I can download just a subset in order to verify that it's matching the root. So say I have one chunk at the very end. What I can do is download that chunk, its parent node, all the way up to the root. And if all of the hashing lines up, then that means that that chunk is valid. This lets you download giant data sets, for instance, like all of Wikipedia or streaming movies, and verify that it's valid as you're downloading it from the network. So this is super important for making things actually scalable. However, hashing isn't the only thing used in peer-to-peer networks. So with hashing, as I mentioned before, if I change a single bit of data, suddenly the whole identifier changes. So how do we actually deal with mutability? The most typical way people do this is using public key cryptography. So essentially, rather than identifying data by its hash, you add an extra level of indirection where you have your public key, which identifies you as a person, an application, something that's saying, hey, I have data that can change over time. And what you can do is then sign data. And when you upload it to the peer-to-peer network, you upload the data, its hash, and the signature. That way, when somebody wants to download data from the network and know that it's from you, they can download the data, download the signature, and then verify that the signature was signed by your private key by using your public key. So for those that haven't done as much public key cryptography, this might be something you might want to read into, but essentially you have two keys. Private one lets you sign, public one lets you verify. You share your public one publicly, and then anyone can verify signatures that you made. So this is used to create mutable logs where I can upload a data set periodically and have the changes propagate throughout the network by anybody that's listening on that public key. So that's kind of the fundamentals of how all peer-to-peer protocols work. There's some more nuance under the hood, like there might be some fancier data structures than just Merkle DAGs. There might be some fancier cryptography, but a lot of them are pretty much that. However, they're glued in different ways. And so we're going to take a look at some of the major protocols that I'm into and some of their strengths and some of the places where they're not as strong, so that you can consider different things when building your applications. So a lot of blockchain things and a lot of peer-to-peer protocols are kind of doing different things. And we'll get into some of the differences actually in a bit. So speaking of protocols, IPFS is probably one that folks have heard if they are in the blockchain space, especially if you're working with NFTs and stuff. So it's an example of a content addressable network where you have data which is hashed to create identifiers and you can download it from the network. One nuance here is that all data in IPFS is individually content addressed. So that means if I have a large data set, all of the files can be individually advertised and looked up on the network. This means that content is deduplicated. So if two websites are both trying to reference bigbuckbunny.mov, peers that are visiting both websites will actually overlap and download chunks of that movie from each other. This means that it's going to be faster for data that's shared. So it's very useful for stuff like a content delivery network. As well, IPFS's network layer is very extendable. So stuff like the Bluetooth I mentioned earlier, it's actually been experimented with in IPFS, and it's all encrypted by default in case you just want the communication. IPFS has several implementations. So if you don't like Go and you're more into Rust or C++, you can actually use those in your project if it can integrate better. There's also a lot of overlap in the IPFS and blockchain communities. So there's a lot of kind of intermingling of ideas and libraries being created. So IPFS's mutability is a little experimental via IPNS. So it hasn't been super fast until very recent, and that's using new features that they're kind of rolling out. So if you have content that needs to update really fast, raw IPFS probably isn't the best bet for you. Content that doesn't update super frequently, but needs to be deduplicated is going to fit really well. That deduplication is also very resource intensive. If I have a data set of, say, 1,000 images, that means that those thousands of images are each individually being announced. And that means peers might be connecting to me a bunch of times and lookups being done a bunch of times to actually get access to them. So this means that if you have a very busy IPFS node with lots of data, you might be dealing with a lot of CPU and disk usage, which depending on your scenario might not work if you're targeting very weak devices. Before I go on to the next one, I see there is a comment. Would it be fair to assume that also the end code is scalable and initiate coding for peer-to-peer is complex and intensive, and the inclusion of private keys? I'm assuming this is talking about different peer-to-peer protocols. So designing your own peer-to-peer protocol can take a decent amount of effort and research, and reusing ones is pretty useful. Just like it makes business sense because you can save money and use their documentation and work with others to like take advantage of communities and to also give back with new things you create. Private keys and all of that are typically pretty efficient, and a lot of interfaces make it pretty easy to use. For instance, with IPNS, publishing a new IPNS website is pretty much just one API call, maybe one more API call to create a key. And generally, a lot of stuff is pretty easy to use. Sorry if I misunderstood your question.
No, apologies. Hopefully you can hear me. I think basically I was typing quite quickly, so I wanted to say although, not also. But I was just thinking in terms of the coding requirements or the resourcing around coding, and how it sounds to me like the initial outlay is quite intensive and quite complex. Yes, it's scalable, but might kind of take a lot of effort in the beginning, is where I was going with this.
That's a really good comment. So one cool thing about peer-to-peer and centralization is peer-to-peer can actually be a lot easier coding-wise. And one of the reasons is the backend. So if you're doing a relatively complex application and expecting to have a decent amount of users, if you're using a client-server model, it means your server needs to be really good at handling lots and lots of people. This means that you need to hire developers to make the server, which is often going to be the different developers from the people creating your front end. You're also going to need people that are managing the server infrastructure and probably paying the Jeff Bezos tax of hosting your data on Amazon. And it actually adds to a whole bunch of stuff if you want to have a centralized application, which is, typical. But the alternative is, what if you get rid of the backend entirely? And what if most of your coding expenses is just the front end and a little bit of glue of defining what the data is and how it's exchanged? In fact, with the web, it becomes even easier because you can get rid of a very decent chunk of problems from your application by just getting rid of the concept of servers entirely and focusing more on, I have my data locally and I might be sending links of my data to my friends and syncing with them directly. You don't have to worry about handling, terabytes of user data because suddenly users aren't storing terabytes of user data all in one place. They're just sharing it directly with the people that actually need access to that data, which coincidentally is also good for stuff like GDPR compliance and all the stuff they're developing around the world. So it's actually not as complex as one might assume, especially if you're building on top of the web, which I'm going to talk about that soon. Comment, does a decentralized internet mainly look like all of us sharing searchable encrypted information on smaller localized network rather than searching one big thing like Google? So it could. The cool thing about decentralized internet is it's not really one thing, and it doesn't really exist as a thing yet. It's kind of something that it's more like a set of tools that you can use for whatever communities you're building for. So if what you want is smaller localized networks like physical networks, you can, and it's easier to do than the current client server architecture. And if you don't want to have one large search indexer, then you can have more private data that's exclusively shared by your friends. Having local search indexes that is querying just your friends rather than a central search. So there's a lot of wiggle room. The main thing is it makes use cases like your decentralized internet comment a lot easier to make as developers, or more specifically as people trying to actually make a product for a community. Speaking of BitTorrent from earlier, BitTorrent is also content addressable, just like IPFS. However, there is the difference that rather than content addressability per chunk of data, it's per an entire collection of data, or a torrent. So if I have a large data set, I'm only finding peers for that data itself. So that means that I'm not doing as much network traffic, but I'm also potentially losing deduplication. So if my website doesn't have anybody replicating it for bigbunny.mov, but your website does, I can't share those peers with BitTorrent. However, BitTorrent overall is very mature software when it comes to peer-to-peer, and this means that there's lots more knowledge about its existence already, and you don't have to teach as much. There's lots of client applications built, so if you're mostly thinking of producing content, it might be easier for people to consume it if it's on BitTorrent. A lot of issues are also solved, for instance, local peer exchange and security and all of that. There's also just a lot of data on the network, for instance, totally legal things that aren't copyright infringement, like Linux CDs and stuff like that. One thing about BitTorrent is it doesn't really have anything for mutability. There's some really experimental stuff that nobody implements. And the other thing about BitTorrent to watch out for is the security guarantees aren't as good. So the newer clients are a little bit better, but a lot of the existing data uses older hash functions that have vulnerabilities. So people potentially could lie to you about data even if you have hashing. So it's got some drawbacks as well. Finally, I'd like to mention Hypercore Protocol, or formerly DAT. And it's kind of different from the previous two in that it is addressed using public keys. So similar to how IPNS will take your public key and then sign the hash of your latest IPFS dataset. When you load a Hypercore Protocol dataset, you use the public key that identifies it. What this also means is that updates are kind of built into the protocol as one of the foundational features. This means that if you have data that changes a lot, it can propagate through the network a lot faster than some other protocols. As well, it's a bit more private by default. With the DHT I mentioned before, people are putting the hashes of their data on the internet, and potentially anybody that finds those hashes can connect to them and download data. So unless you're adding an extra layer of encryption to your data, you're actually potentially exposing it to the world. So stuff you upload on BitTorrent and on IPFS is not private. So I wouldn't be putting my family photos on there without an extra layer of encryption. Hypercore Protocol kind of solves that. In the replication protocol, if you don't have that public key, you can't access it, and the public key isn't advertised on the network. So it's a bit safer by default. However, there's only one implementation in Node.js, which might not be ideal for some people. So in terms of which one you should use, It depends. It depends on what you're trying to do. It depends on which communities you're working with, depends on what trade-offs are more important for you. So usually it's good to sit down and look at what is around. However, if you're unsure and you don't really know your constraints, just pick whatever is easiest for your team to use. Because getting something out there and getting actually some iterations together is going to be very important for experimenting and actually figuring out what works for your product. So those are the protocols and how they work. Let's talk about what these protocols are really useful for. That is this term called local first software. So it's software that works locally on your machine by default and can upgrade with the network as it gets connected to more machines. So that means software written in this style will work fully offline when you have 0 networks. It should work on the local network use case where you might not be connected to the internet, which lets you do social features, and it should work with the internet once you get connected. This kind of gives you progressive enhancements. And with peer-to-peer software, it's really easy to get these benefits without having to do really, really complex engineering things, the way you would if you, say, wanted to add local first to your Twitter clone or Notes app or whatever. So local first software is something that I think people should look into for making software that's more resilient, and also to focus on the data and on people owning their data rather than focusing on aggregating people's data and monetizing on it. So specifically, one thing I think is useful for building local first software is the web. So what if we take peer-to-peer, we take the ease of application development of the web and we glue them together. So right now, when you're making a web app and talking to this server, you're going to need a URL for the server and some sort of method. The URL usually contains the protocol, either HTTPS, or if you're, insecure, HTTP, the server name, and the actual data you're trying to interact with. And then you tell it you either want to get some data, you want to put some data here, or delete some data, or whatever else. The server will then give you back a status saying, hey, that's cool with 200, or I don't know what you're talking about with 404, and optionally the actual data you're looking for. So this is something that most developers these days are pretty familiar with, the ones that are interacting with backends. So what if we could take those exact same metaphors and apply them to peer-to-peer URLs? What if I could get an IPFS URL and get back data the same way I would get data from a web server? What if I could then post data to a hyper URL in the same way that I would with a web server? So what this gives us is essentially the same interface as servers without having to deal with all of the servers. So without having to learn how to orchestrate virtual machines and all of that scaling mumbo jumbo. Instead, you can just work with having your developers save and load data and then focus on sharing the identifiers of the data between the people that actually need it. So this is something available right now today that you can play around with in my web browser Agrigor, and also some other experimental features in things like Brave browser with IPFS. But what it lets you do is everywhere in a web page where you have a link to something, say it's a script or an image or a video or the page itself, rather than loading from HTTP, you can now load it from a peer-to-peer network. And similarly, rather than having to share your data with a server, to propagate it, you can instead upload it on the peer-to-peer network and then share just your link with somebody. So this is really powerful, especially when you consider that it's not just the data that you can share, but it's actually the applications themselves. So what happens when we're in that, like festival in the woods scenario where one of us has downloaded the schedule app for when all of the people are performing? How do I actually get that to somebody else in a usable way without the internet? Right now, it's a huge pain in the ass if it's possible at all, because you don't have app stores. You don't really have a way to connect to each other that's easy to use. But with peer-to-peer and local first software as your building block, you can just share the link over your local connection and share the data itself. Now that you have a copy of that data, you can go and share it with somebody else. And the viral propagation that we see in ideas and information suddenly gets turned into the viral propagation of data as a whole. So the same way I could tell you some hot gossip about Janet, can also show you this cool new cookie clicker app and share it with you person to person rather than through intermediaries. So Agrigor currently supports a few of these peer-to-peer protocols, namely IPFS, BitTorrent, Hypercore protocol, and also some weird ones like Gemini, which isn't even really peer-to-peer, but is super cool. And since they have similar metaphors, your apps can mix and match the best of all worlds while also focusing more on the front end and focusing more on the actual application that you're making and how people interact with it rather than all of this backend server and service orchestration. So as I mentioned before, there's some benefits to this where you don't have to worry as much about censorship, or you don't have to worry as much about servers going down or companies losing business. You kind of get a lot of the things that you want in an app in terms of sharing data, but without a lot of the downsides of having all of the data in one place. So regarding where you might want to use this technology, if you really value having open data by default, this is very useful because the person has all of their data locally and they're the ones that own them. If they want, they can take the URL of their data and potentially move it to a different app or to their own version of an app without having to go through extra steps of importing and exporting. If you're targeting low internet environments, for instance, like people in the rainforest trying to exchange data, this can be really useful because you don't have to build additional stuff to deal with replicating data and dealing with internet time when a lot of it can be done automatically for you. As well, this can give resilience against censorship. So say you are, a bunch of gay people trying to do the equivalent of decentralized TikTok, you can say lesbian as much as you want without someone coming in and being like, hey, you can't talk to your friends about lesbians anymore. As well, it's really cool for situations where you want more local consensus rather than global consensus, where you're more interested in working with people within an actual network of people rather than an impersonal, say, global ledger where you need something the same on all sides. But in the global case, there's a lot more coordination and centralization and resiliency that you lose. So that's kind of an overview of the decentralized web and specifically like peer-to-peer stuff. So one comment I'm seeing, can you talk about Agrigor and browsers versus Tor and Brave, etc.? So personally, I made Agrigor because I wanted it to exist and the stuff I wanted to exist didn't exist yet. But my hope is that we just don't need it anymore because other browsers will actually implement it. So I'm working with things like Protocol Labs to standardize the IPFS interfaces in Agrigor to make them also standard in Brave and potentially other web browsers down the line that are interested in supporting peer-to-peer. Regarding Tor, it's a little different because it's not using peer-to-peer data structures. It's really cool for securely accessing centralized services. And it's a little easier to set up your own server on it. It would also be cool to see if we can combine Tor with peer-to-peer to make it even more anonymous and secure for cases where you need that. Yeah, so Brave supports IPFS protocol handlers for loading data. We just put together a test suite for uploading data, which hasn't really been implemented yet. But there is like kind of a path forward where these protocols can just be kind of widespread enough that people are just going to be using them. Right now, it's a bit more experimental, and it's up to the people that actually see benefits in using decentralization in their applications to kind of like take the lead and be like, hey, we're going to actually make this work with our communities and our projects. I encourage people to like search up words that they aren't familiar with or stuff they want to learn more about. This is kind of the high level overview, and a lot of the times it might just be enough to more or less know what you're talking about when you're talking about like just talking to developers and being like, hey, can we use the DHT, or like, oh, what's the security model?
Yeah, so one thing I guess I would mention that you mentioned mutability in particular with IPFS. So Ceramic, which is the protocol that I work on mostly for day-to-day work, is one of the solutions to mutability on IPFS. Yeah, that's something that I'd love to see included in the slides at some point.
Yeah. That could be fun. I should do some learning on it. Oh, since we have time, want me to make a live code a peer-to-peer website?
Yeah, if people want to stick around and see some live coding, definitely we can do that. One thing, excuse me, one thing that I did want to do before people hop off is just briefly mention the next Fireside chat that we have. So this coming Thursday, we'll be having another one, and that will be on DeFi. If you received the invitation for this one, you will receive a similar invitation for that one. So you won't miss out about that.
Sweet.
All right, I'll let you take it away.
I just made a new peer-to-peer website in Agrigor. So what I can do is use pet names for public keys on my local machine. So I just created a new archive on my browser. And if I want to upload a new file, I can use the browser fetch API by calling fetch. I'm just going to copy paste something I did before. So this is how a lot of developers interact with web servers using fetch. You specify the URL you want to interact with, the method, and in this case, I'm going to put some data to the website saying, I like cats. I hit enter, it loaded up, and if I refresh, oh, wait, did I get the URL
You were just missing a letter, yeah, in thing.
Yeah, I'm not very good at spelling. All right, cool. So I just made a peer-to-peer website right there. So if you want to visit it, here is the URL, and you should be able to load it straight from me, hopefully, if everything works out. But there we go. I just made a peer-to-peer website with one line of code, and that is kind of how easy it is. Now, rather than setting up a backend and all of this validation and stuff to upload a file and having the developers for all of that, you could potentially have someone that is purely a front-end developer do this. So someone that's more comfortable with actually making graphics and maybe a little bit of JavaScript, suddenly they can do all of the fancy data loading and data sharing. And this severely reduces the barrier to entry for making things. So I think this is going to be really cool for when youth start using it, because they can just make their own things without having to bother with all that extra server mumbo jumbo. And I'm hoping that we can maybe get a resurgence of the old web of people just making stuff for themselves and their friends. Well,
great. If no other questions, I think we are all set for today.
Sweet.
Stick around a couple more minutes if there's any last minute questions. But again, thank you everyone for being here. Thank you, Mauve, for being here. This is really fantastic, and I'll share the recording soon.
Good question. So if we have the hyper, like that link, we would just put that into like the Agrigor browser, and then we'd be able to view it.
Yep. So either Agrigor browser or Beaker browser. And so what that'll do is my computer is currently advertising on the DHT for that URL. Oh, not the URL in my browser, the one that I posted in the chat. So this is like my local URL. The really gross one I posted is the actual public key, and that's what you can actually find me with.
Could you talk more about the Beaker browser? I haven't used this before.
So Beaker browser is similar to Agrigor in that it's a peer-to-peer web browser. However, it's not really actively maintained anymore, but it was kind of like the first one that was really messing around with all this. So Paul Frazee did a lot of great work kind of laying the foundations. It has some really cool features if you want to play with it, probably more features than Agrigor, but I've got more protocols, so.
Mauve, I don't know, this is perhaps just a little bit of a side chat, but I don't know if you've heard of this new view of redeveloping the web, the World Wide Web. And there were lots of conversations just before COVID at the Web Summit and stuff like that.
Mm-hmm.
And when you were going through your slides, you talked about peer-to-peer, and perhaps that could be a way of, you know, going back to the old days where people just shared things rather than having it, you know, this being this big commercialized space. What are your thoughts about that? You know, do you think peer-to-peer really is the way to go for the World Wide Web in the future?
Absolutely. I think especially as people are becoming a little more conscious of privacy and a little more conscious about, you know, all of the sussy things that businesses are doing with their corporation, with their data, I feel like there's a bit more for users. But personally, as a developer, the thing that really encourages me is that it's easier. I genuinely believe that peer-to-peer software is a better foundation for the web because it's more aligned with the decentralized nature of the web, and it enables more people to actually create content. Right now on the legacy web, if I want to make a new website, I'm either saying this company owns my website and I'm just waiting for them to shut down, or I have to learn how to do backend development and DNS and have the money for actually hosting all of that. With peer-to-peer, anybody can make it, and anybody can make stuff without even the internet. Like I'm imagining, let's put on our conspiracy hats and say that there's like a climate disaster and infrastructure breaks. The current web is not equipped for that, because as soon as Amazon data centers go down, like probably more than half of our internet is useless, and more than half of our technology is useless. With this, if you have like, you know, even like a city that wants to just reuse their existing physical infrastructure, they can just use it and take advantage of the existing networks and connections that we have without having to relinquish control to corporations who knows where.
That's a good, yeah.
It's Oh, yeah, sorry, just to interject. One thing that it's not as good for is extracting lots and lots of money from lots and lots of people. So if you want to extract lots and lots of money from people, centralized might be easier, because then you can just have everyone's data and sell all of their data and hold all of their data as ransom. So peer-to-peer is less effective for that. But I think also, if businesses or communities start using it, suddenly those large businesses that are like, oh, you're going to give me all your data to use our service are, you know, less appealing, because they're probably going to be more expensive to maintain compared to local first. And, you know, they're going to be less personal than stuff made by actual communities. I don't know. I have a lot of opinions about this, sadly.
But really interesting. Thank you. This has been really, really a useful conversation and very exciting, actually. I've learned quite a lot. Thank you.
I think I'll also be in the Discord for a bit if anyone wants to ping me.
Oh, cool.
One more question, if I can.
Yeah.
So say like a business wanted to host like their sort of like e-commerce, like selling their product on a site like this. But they would have to like have some kind of payment method that involved, you know, like running it through banks as we know them. Would that be possible? Like to have like a pay gate kind of thing going on?
Yes. So actually, one thing that I wanted to mention that I forgot was there's this thing called Grant for the Web and this spec called web monetization. It's kind of making payment processing on websites more decentralized, so people can bring their own payment processing and websites can bring their own payment processing. And then this protocol kind of helps navigate between them. So one thing that I've been wanting to do is partner with a community that wants to use decentralized tech and decentralized payments and work together on a grant and find some money to pay the community to develop something for themselves. But effectively, you can decouple the serving of the content from the payment processing. You could either use an actual server for the payment processing for legacy reasons, or you could use this new web monetization if that's more up your alley. Web monetization is probably the thing that would be most aligned with what you mentioned.
All right. I think this is a good place to wrap. So again, thank you, everyone. Thank you, Mauve. And we will see you all soon.
Thank you. Have a good night.
Bye.